Let us take up new theorem, that is Cauchy mean value theorem. Theorem statements: if f of x and g of x are two functions continuous in a closed interval AB, second condition, and both functions should be differentiable in open interval AB, third condition, g dash of x is not equal to 0 for all x belonging to open interval AB because we have differentiated, so open interval AB, then there exists at least one real C in between A and B such that f dash of C by g dash of C is nothing but f of B minus f of A whole divided by g of B minus g of A. Put A has this term, that is f of B minus f of A whole divided by g of B minus g of A. To establish the denominator term is not equal to 0. If it occur to be 0, 1 over 0, that is infinity, does not exist. Contrapositively, let us assume it is equal to 0. Whenever we are proving a theorem, let us move in opposite direction. So what will occur in contrary? Let us prove it as assumption. So all conditions is satisfied. So to prove this denominator is not 0, contrapositively let us assume it is equal to 0. So minus g of A will become plus g of A. So all conditions of Rolle's theorem, here all three is satisfied for function g of x. So by Rolle's theorem there exists always one real C in between the 2 points whichever we have chosen such that g dash of C is equal to 0. This contradicts third condition of Cauchy mean value theorem, but it should be not equal to 0. Here it came out to be g dash of C is equal to 0. So g of B minus g of A is not equal to 0. Therefore A is well defined. Defining phi of x has f of x minus f of A minus A times of g of x minus g of A in the closed interval AB. First condition, phi of x is continuous in the closed interval AB. Phi of x is a differentiable in open interval AB given f of x and g of x are continuous in a closed interval AB. Phi should be continuous in a closed interval AB given f of x and g of x should be differentiable in open interval AB. Phi of x should be differentiable in open interval AB. Phi dash of x, that is f dash of x minus 0 minus A times of g dash of x minus 0, that is f dash of x minus A times of g dash of x. Next, third condition, phi of A is equal to f of A minus A times of g of A minus g of A, that is cancel, it also will become 0. Plus minus cancel, A times of 0, that is 0. Next, phi of B, f of B minus f of A minus A times of g of B minus g of A, that is f of B minus f of A minus A is this, f of B minus f of A whole divided by B, g of B minus g of A into g of B minus g of A, that is f of b minus f of a minus f of b plus f of a. Plus minus minus plus cancel 0. So phi of a is equal to phi of b. All conditions of Rolle's theorem satisfied for function phi of x. So by Rolle's theorem, there exists real C in between a and v such that phi dash of c is equal to 0, that is f dash of c minus a times of g dash of c is equal to 0. Shift to other side, that is minus will become plus a g dash of c, that is f dash of c by g dash of c will become a. Okay. A is nothing but f of b minus f of a whole divided by g of b minus g of a. That we have established. That's all. Next, coming to problems. Verify Cauchy mean value theorem for f of x, that is e power x, g of x, e power minus x in a closed interval ab. Proof: f of x and g of x are continuous in a closed interval ab. It should be differentiable in open interval ab. Differentiate it, e power x is e power x only, g dash of x, e power minus x is there, so minus 1 of e power minus x. Differentiation of x is 1, minus 1, chain rule. So third condition, g dash of x is not equal to 0 for all x belonging to open interval ab. These two conditions are same for Rolle's and Lagrange's mean value theorem. Extra condition is this: g dash of x should be not equal to 0 in case of Cauchy mean value theorem. Okay, you keep that in mind. All conditions of Cauchy mean value theorem are satisfied. Therefore, by Cauchy mean value theorem, there exists a real C in between a and b such that f dash of c by g dash of c is equal to f of b minus f of a whole divided by g of b minus g of a. Okay, f dash of c is nothing but e power c minus e power minus c. F of b, that is e power b minus e power a whole divided by e power minus b minus e power minus a. So minus e power a, you can write this as 1 over e power b minus 1 over e power a. So minus e power c, law of indices, a power m by a power n, that is a power m minus n. Take LCM. So that is minus e power 2c e power b minus e power a by 1 into e power a e power b whole divided by e power a minus e power b, that is minus e power a minus e power b into e power b e power a whole divided by e power a minus e power b, cancel it. So that is e power minus 2c is equal to e minus e power b plus a minus, let it be e power 2c, that is e power b plus a. This minus will come here, not here. Okay, cancel it. 2c is equal to b plus a. C is nothing but b plus a by 2, and you know this relation, that is am between two numbers a and b. So C is this point a plus b by 2 belonging to open interval ab. That's all. Next, second problem. Verify Cauchy mean value theorem for f of x, that is root of x, g of x, 1 over root of x in a closed interval ab 0 does not belong into closed interval AB. Proof: f of x, g of x continuous in a closed interval AB. It should be differentiable in open interval AB. Differentiate it f dash of x root x 1 over 2 root x, g dash of x. First root x you can write this as half x bar half, x bar minus half, that is minus half, x bar minus half minus 1, that is minus half x bar minus, that is minus half x bar minus 3 by 2. You can write like this, g dash of x. Okay. So third condition, g dash of x is not equal to 0 for all x belonging to open interval AB. All conditions of Cauchy mean value theorem satisfied. By Cauchy mean value theorem, there exist at least one real C in between A and B such that f dash of C by g dash of C, that is f of B minus f of A whole divided by g of B minus g of A, 1 over 2 root C whole divided by minus 1 over 2 C root C is equal to root B minus root A whole divided by 1 over root B minus 1 over root A. So that is 1 over 2 root C, 1 over 2 root C will get cancelled, you are left with minus C, that is root B minus root A whole divided by, take LCM, root A minus root B whole divided by root A into root B. So that is minus C is equal to minus root A minus root B whole divided by 1 into root of A into root of B whole divided by root of A minus root of B. Cancel, minus minus will get cancelled. C is equal to root of AB, and this is geometric mean between A and B. So C is nothing but root of AB belonging open interval AB. This completes your proof.